In topic 5, we're going to be looking at domain and range. So the domain and range tell us the values where the graph or data exists. And if you remember from topic 2, we said the domain is the set of x values, or in other words, the input, and the range is the set of y values, or the output. Now, domain and range are a new concept to you, but how I like to describe it is think of a normal day and the temperature, how it goes up and down. And we could say the range of the temperatures, if the lowest temperature was, let's say, -7, and then it went up to +9 throughout the day, we would say the range of temperatures was -7 to 9. So that would be the range of the temperature. So we're going to be doing the same thing with a graph and the data we're given there. Now, there's a couple different ways that we can write domain and range. So if the points on the graph are connected, we have two ways. We have interval notation or set notation. So this is if all the points on the graph are connected by a line, as you can see in that little picture over there. Now, I'm going to teach you how to do both interval notation and set notation, but you can choose one or the other to do on any assignment or test. However, moving forward with Precal, they usually use set notation. So I would try to get the hang of that one if I were to recommend one over the other. So let's start with interval notation. Interval notation uses brackets. So we either have the round brackets or we have the square brackets. And we use those to describe the interval. Now, we would use the rounded brackets if the data does not include the end point, or if the data goes to infinity on one of the ends. And we will see that in examples coming up. We would use the square brackets if the data includes the endpoints. Now, moving on to set notation, this one, instead of using brackets, we use the greater than or less than symbols to describe the interval. So this time, if our data doesn't include the endpoints, we would use the two symbols like this that does not have that equal sign underneath it. So we would just use the standard greater than or less than symbols. However, if the data does include those endpoints, that's when we add in the equal to symbol. So we would use greater than or equal to, or less than or equal to. We're also going to be introducing this new way of writing math here. So if the data includes all the x or y values, so if it goes from -infinity to +infinity, we say x is an element of the real numbers, or y is an element of the real numbers. So we use this symbol, and it reads out loud as x is an element of the real numbers. And if you were to write that down on your paper, you would do X, and then I kind of do a curved E like that, and then the R to represent real numbers, do two sticks like that, and then finish off the R like that. So that says X is an element of the real numbers, or Y is an element of the real numbers. So this is two different ways to write the domain and range if the points are connected, but if the points are not connected, what we do instead is we just list all the x values for the domain and all the y values for the range, and we just put them in a list in these set brackets like so. So then you would just list off the numbers like so, and then that would be the domain. So these would be all the x values on the graph. And then for the range, you would list all the y values on the graph, whatever they may be. Now, we will look at this further in the examples, and it'll make a lot more sense. So example 1, determine if each of the following are functions and find the domain and range. So for all of these examples, I'm going to give you the answer in both interval notation and set notation, but you can choose one or the other. So let's start with example 1a. First, let's see if this is a function. So we would do our vertical line test and see if we can get all the way through the graph without touching it more than once. And yes, we would be able to. So yes, this is a function. And now let's get into writing the domain and range. So let's start with the interval notation. So if we're looking at the domain, so I'm just going to put D for domain, we need to look at all the x values that our graph touches. And what I mean by our graph is this line that we have here. Now, if it's going off the graph on the edge like this, that means we can assume that this is going to continue this way forever and ever. Okay, so if it touches the edge of the graph, we can assume that it's going to continue the exact same pattern off of the graph forever and ever. So when we're looking at domain, we need to start with the lowest x value that the graph touches. So by lowest, I mean if we're looking at the x-axis, which is right here, we need to look at the lowest value this way that our graph is going to reach. Well, if this side of our graph is going this way forever and ever, it's going to go until negative infinity on the x values, right? Because if we're going this way more and more and more, it'll eventually reach negative infinity. So the lowest value of the x's that our graph hits is negative infinity. So for interval notation, we're going to put negative infinity, and now we need to use brackets for this interval notation. So we're either going to use a round bracket or a square bracket. Now when we have an infinity symbol, we need to use a round bracket next to it. So that is the lowest x value that our graph hits. And now let's look at the highest x value that a graph hits. So we're going to follow all of our x values. So our eyes are like looking this way on the graph, and we're looking across, and eventually we get to this point right here. So let's see what the highest x value is that this graph hits. So it would be right here, which is 5. So the highest x value is 5. So I'm going to put 5 here. And then we need to think, do we use a round bracket or a square bracket? Well, is this point included in the graph or not? And I don't know if you remember, but we were talking about open circles and closed circles. Is this an open or a closed circle? Well, this one right here is a closed circle, so that means it is included in our graph. So because of that, we are going to use a square bracket on the side of the interval with the 5. So therefore, our domain is negative infinity to 5. Now let's do the range. So we're going to do the same thing, but this time with the y value. So instead of looking from left to right, we are going to scan our graph from the bottom to the top. So the first thing we have to do is think about the lowest y value that our graph is going to reach. So if we imagine that this side of the graph's going this way forever and ever and ever, we're going to start by scanning the y values from the lowest point. So let's pretend our eyes are down here and we're moving our way up the graph. What is the lowest y value that our graph is going to hit? Well, if this is continuing down forever and ever that way, we are going to hit negative infinity on the y. That is going to be the lowest y value we hit. So again, we're going to use a round bracket because we're writing infinity, and we're going to put negative infinity. So that's the lowest y value that our graph is going to hit. And now let's see the highest y value our graph is going to hit. So if our eyes are moving up the graph, we want to go until we reach the last point of our graph, which is right here. That is the highest y value that our graph reaches, which is at 2. So we're going to do a 2 here, and is that point included? Yes, it is. It's not an open circle there, so then we're going to put a square bracket. So therefore, our range is from negative infinity all the way up to 2. So those are all the y values included in our graph. So that's how we would write it as interval notation. And now let's see how we would write it as set notation. So set notation uses the greater than or less than signs. So for domain, the way we would write this is we would put that x is always going to be less than or equal to 5, because 5 is our greatest x value, and all of the x values are lower than 5. Because 5 is our greatest x value, and all the other x values included in our graph are lower than 5. So we are going to put that x, which is our domain, is always going to be less than or equal to, we put this equal sign because 5 is included in there, so x is always less than or equal to 5. And for the range, well, we already see that our range is from negative infinity to 2, so therefore y, because range is y, is always going to be less than or equal to 2. Because 2 is the highest point in our range, and all the other y values are less than 2. So y is always less than or equal to 2, and that would be the domain and range for this graph. Next, let's look at B. So B is a little bit easier because these points are not connected. So I'm just going to put a little note, points not connected. Now, because they're not connected, it's actually easier for us to write this domain and range because all we have to do is look at all the x values and write them in a set bracket, and then look at all the y values and write them in a set bracket as well. So I'm going to put domain, and we're going to open up these set brackets. And now let's list all the x values we see on this graph. So let's start with the lowest one, which would be right here. So the first domain value we have would be 1, because x is equal to 1 on this point. This one is 2. This one here is 4. This one and this one are both 5. So we're only going to write the 5 once. We don't have to repeat values. And then this point here is at x is equal to 6. So 1, 2, 4, 5, and 6 are all the x values on the graph. Next, let's look at the y values. So we're going to put range. I'm going to open our set brackets. So let's start off with the lowest y value, which would be right here. So that would be -1. Then if we go to this one, that's at 0. This one is at 1. Another one at 2, 3, and finally 6. So this here would be the range of all these values. So those are all the y values that appear on this graph. And that's it for the domain and range for that one. Next, let's look at C. So for C, we now have one closed circle and an open circle on this other side. So let's start with interval notation. Oh, sorry, and I forgot to actually state if this last one is a function or not. So we would do the vertical line test, but once we get to this point or this line here with our vertical line, it would touch more than one point at a time. So I'm going to put no, not a function. So for C, let's just start that right away. Is this one a function? Yes, it would be. It would pass that vertical line test. So now let's do that domain and range. So domain. So remember, domain is all the x values. So let's start off. What is the lowest x value we see? So your eyes are going to scan the graph from left to right. So the first time we see the graph, it would be right here. And that x value is -3. And does it include that value? Yes, it does, because it's a closed circle. So I'm going to put a square bracket, and I'm going to put -3. And then comma. And then what is the biggest or the last value on our graph, or the biggest x value that we see on the graph? Well, that would be here at +5. Now this time, does it include that point? Well, it's an open circle, so it does not include that point. So on this side of the interval, I'm going to put a round bracket because it does not include 5, but it includes every single point up until then. And now let's look at the range. So for range, we're going to scan the graph from the bottom to the top. So if we're taking our eyes and we're looking up at the graph from the bottom to the top, when is the first time we see the graph? Well, that would be at this point. And what is that y value? That is 3. So 3. And does it include that point? Well, it's colored in. It sure does. So we're going to use a square bracket. And then if we continue up the graph, the last or the biggest y value we get would be at this point, which is 7. And it does not include that point because it's an open circle. So 3 to 7 is the range. So now let's write this in set notation. So we need to say that x is going to be in between -3 and 5 for the domain. So what we're going to do is we're going to put an x, and we're going to say that -3 is less than or equal to x, and we put the less than or equal to symbol because it is including that point. It's colored in, so it's equal to that point as well. So -3 is less than or equal to x, which is less than 5. So this symbol does not, or this side of it does not have that equal to symbol, and that's because it's not equal to 5. It's just going to be less than 5. So how this is reading is that x is smushed in between -3 and 5 for those x values. But you have to be careful which ones you put the equal sign on and which ones you don't. So next, let's do the same thing with the range. This time we're looking at the y values. So this time the y values are smushed between 3 and 7, as you can see where we did that interval notation. So they're between 3 and 7. So we're going to put 3. We always start with the lowest value, is less than or equal to y, and I put the equal to sign because this point's colored in. And then the next point is not colored in. It's an open circle, so I'm only going to put a less than sign and then the 7. So 3 is less than or equal to y, which is less than 7. So y is smushed in between 3 and 7. Those are all the y values, and that would be the domain and range for that one. In this last one, let's check if it's a function first. So yes, it would pass the vertical line test. So it is a function. And then we'll do that interval notation, domain and range first. So for domain, this graph is going off into infinity this way and that way. So this one's going to keep going wider and higher like that. So for the domain, we have to think what's the lowest x value that this graph is ever going to reach. Well, if it keeps going up this way, it's going to keep getting wider in both directions. So it's actually going to be eventually hitting negative infinity in the domain. So the lowest domain we hit is negative infinity. That's going to be the lowest x value that our graph ever reaches. And then for the highest x value, well, it's the same thing, except in the positive direction. It'll eventually reach positive infinity because it's going to keep getting wider and wider and wider and wider all the way until infinity. So that domain was really easy. Let's do the range. So for the range, the lowest y value, so now we have to scan our graph from the bottom to the top. The first time we see our graph going from the bottom to the top is right at this point here. So what is the y value on that point? Well, that would be 0. And is that included in the graph? Yes, it is. There's no open circle there, so we would put a square bracket and a 0. And remember, for this one, we always use the round brackets for infinities. Then we have to think, what's the biggest y value that this is ever going to reach? Well, our graph is continuously going up higher and higher infinitely. So the highest y value is going to be positive infinity. And that would always be a a round bracket. So now let's write this as set notation. So for the domain, well, this time the domain goes from negative infinity to positive infinity. So when it includes every single number, we need to write it with those special characters that we saw up here. So what we're going to say, since the domain includes every single number possible, we're going to put x is an element of the real numbers, and that would be the domain for that one. Then for the range, well, the range goes from 0 to infinity. In other words, we could say that y is always greater than or equal to 0 because the lowest y point is 0 and it's always going to be greater than or equal to that. So that would be the domain and range in set notation. Finally, for example 2, this one's a little bit easier. Here is a graph of the function g of x is equal to 4x minus 3. And we can use any letter here just so you know. It doesn't have to be f of x. It could be g of x, h of x, and so on. So this says, what is the range when the domain value is 3? Well, in other words, what is the y when the x value is 3? So let's look on the x-axis, which is this one, and let's find where the domain is 3, or where x is 3. So that would be here, and if we follow that up to our graph, we hit this point. So then we would say, okay, what's the y value from that point? So we would follow that along the side And we would eventually get to, looks like, I don't know, 9-ish, 8.5. So we'll put when the domain is 3, or in other words, x is equal to 3, then the range is, and we said approximately 9. So we'll say that y is equal to 9. So when the domain is 3, the range is 9. And again, let's do the same thing, but this time they give us the range. So it's asking, what is the domain when the range is -7? So if we look at our graph, the range is the y values and the domain's the x. So let's look at where y is -7. So that would be at this point. Oh, sorry, no, not that point. It would be right here. And if we follow that to our graph, it hits right there. So if we follow that up to the x-axis, we are at -1. So we'll say when the range is -7, the domain is -1. And we'll leave it at that.